Hi all, let us try to attempt few A-level questions to strengthen up your confidence in simple harmonic motion. Let us try to attempt the first one. An object of mass 2.1 kg is executing simple harmonic motion attached to a spring with spring constant K 280 Newton per meter. When the object is 0.020 meter from its equilibrium position, it is moving with a speed of 0.55 meter per second. Calculate the amplitude of the motion and the maximum velocity attained by the object. For step 1, let us dig out all the important values in these questions. Mass is 2.1 kilogram. Spring constant K given as 280 Newton per meter. The displacement x from its equilibrium position is 0.020 meter, and the speed of the particles, which is given 0.55 meter per second. The particle so-called is object. We can find the amplitude by using the speed of the particle. V equals to positive negative omega square root of a squared minus x squared. V is given, omega we have to find out, a is the amplitude which we're going to find the section A, x is the displacement which is given as 0.020 meter. An object executing simple harmonic motion attached to a spring. So, the period t equals to 2 pi square root of mass over spring constant, or we call it t equals to 2 pi di bawah payung makan ketupat. Just to make you memorize the formula. So, t equals to 2 pi square root of 2.1 divided by 280 Newton per meter. Press the calculator to get the value of t. If you don't have calculator, calculate later. So, 2.1 divided by 280 square root answer times 2 pi. So, you will get 0.544 second. You can leave it in 3 decimal point or 2 decimal points. So once you get the period, now we can get the omega equals to 2 pi over period, which is equals to 2 pi divided by 0.544 second. So you will get 11.55 radius per second. So we managed to get omega equals to 11.55 radius per second. So we're going to substitute this value in this formula, which is V equals to positive negative omega square root a squared minus x squared. V is 0.55 meter per second. Positive negative omega is 11.55 radius per second. Amplitude we're going to find, and the displacement is 0.020 meter. So you will get the amplitude A equals to 0.0516 meter. Next, to find the maximum velocity attained by the object, we're going to use the formula for section B. Vmax equals to A times omega. A equals to 0.0516 meter times the omega is 11.55 radians per second. So you will get 0.596 meter per second. So the answer here is 0.596. Change to 6, the answer should be 6. For questions number 2, the length of a simple pendulum is 75.0 cm and it is released at an angle 8 degree to the vertical. Calculate A. The period of the oscillation, B. the pendulum's bob speed and acceleration when it passes through the lowest point of the swing. Given the value of G is 9.81 meter per second square. To find the period of oscillation for the pendulum, we straight away use the formula T equals to 2 pi square root of L over G. L is the length of the pendulum, G is 9.81 meter per second square, or T equals to 2 pi di bawah payung letih gila. T equals to 2 pi di bawah payung letih gila sounds better for your memorizing part. So T equals to 2 pi, L equals to 75 cm, convert to meter, 0.75 meter divided by 9.81 meter per second square, and we will get 1.74 second. Simple like a bubble without giving you any trouble. So the period of the oscillation, we got it, 1.74 second. For the section B, the pendulum's bob speed and acceleration when it passes through the lowest point of the swing. So at lowest point, the kinetic energy is maximum. When the kinetic energy maximum, the speed of the bob is maximum. So the pendulum's bob speed should be maximum. So Vmax equals to amplitude times omega. So amplitudes times omega, omega equals to 2 pi over T. I can substitute this T here, where the amplitude is hanging, have to find. The question is already written that the simple pendulum of 75 cm is released at angle 8 degree. So let us draw the figure, which is oscillate at 8 degree. And this is the length. This is the x. The x here is equals to the amplitude. from sine theta, which is equals to x over L, sine theta for the small angle theta equals to theta for small angle. So theta equals to x over L. So x equals to amplitude equals to theta times L. So theta is 8 degree. We have to convert to pi radian by times pi over 180 degree times 0.75 meter. Then you will get the amplitude 0.1047 meter. So now we can substitute this amplitude in this formula, which is V max equals to A times omega. So now A equals to 0.1047 times 2 pi divided by time 1.74 second. 0.378 meter per second. So the answer is given 0.378 meter per second. So this is going to be the final answer. Let us try to solve this problem. A mass which hangs from the end of a vertical helical spring is in simple harmonic motion of amplitude 2 cm. If 3 complete oscillations take 4.0 seconds, determine the acceleration of the mass A at the equilibrium position, B when the displacement is maximum. So, at the equilibrium position, the acceleration of the body undergoing oscillating 0.378 meter per second. So the answer is given 0.378 meter per second. So this is going to be the final answer. Let us try to solve this problem. A mass which hangs from the end of a vertical helical spring is in simple harmonic motion of amplitude 2 cm. If 3 complete oscillations take 4.0 seconds, determine the acceleration of the mass A at the equilibrium position, B when the displacement is maximum. So, at equilibrium position, the acceleration of the body undergoing oscillation is 0. So, the acceleration is 0. For section B, determine the acceleration of the mass when the displacement is maximum. By using the formula of acceleration, which is equals to negative omega square x, x is the amplitude. We can find the omega by using this formula. Omega equals to 2 pi f, f equals to 1 over period, which is divided by period. So 2 pi divided by 4 seconds into 3 oscillation, because the questions said if 3 complete oscillations take 4 seconds, so the period 4 seconds divided by 3 complete oscillation, so you will get 6 pi over 4 radius per second. Then we substitute this omega in this equation. A equals to negative omega squared x. You can put it modulus to show the acceleration is always positive, and x is 2 cm is the amplitude. You can leave it in cm, so you will get 44.4 centimeter per second square or 0.44 meter per second square. For questions number 2, a body of mass 2 kg moves in simple harmonic motion. The displacement x from the equilibrium position at time t is given by x equals to 6 sine 2 in bracket pi t plus pi over 6. When x is in meter and t is in seconds, determine the amplitude, period and phase angle of the simple harmonic motion, the maximum acceleration of the motion, and the kinetic energy of the body at time t equals to 5 seconds. So from the displacement equation, rewrite the equation for x equals to 6 sine 2 times inside 2 pi t plus 2 pi 6. Compare this equation to the general equation which is written here. X equals to a sine in bracket omega t plus phase angle. This is symbol for phase angle. So to answer the section A, the amplitude is 6 meter, the omega is 2 pi radians per second, and the phase angle is 2 pi over 6 or pi over 3 radian. For the maximum acceleration, we can use the formula A maximum equals to negative omega square x. For maximum, we should put modulus. By substitute this omega by 2 pi square times 6 meter, x is the amplitude, you will get 24.0 pi square meter per second square. This is the section A solution. You can have a look again. And this is for section B. For section C, the questions ask you to find out the kinetic energy of the body at time t equals to 5 seconds. To answer this question, we have to recognize the formula for kinetic energy, which is equals to half mv squared. The kinetic energy equals to half mv squared equals to half m. The v is the velocity of the particle, which is positive negative omega square root a squared minus x square square. The whole thing should square. For the first step, you have to find the value for the x, which is displacement x. So by substituting this t equals to 5 seconds in this equation, make sure your calculator change to radian, substitute all the values in that equation accordingly. You will get the displacement x is 3 square root 3 meter. Now you can substitute this value into this formula as the displacement x at t equals to 5 seconds. So this is the value of x for t equals to 5 seconds. So once you substitute all the values in this formula, which is the whole thing here, you should square, you will get 355 joule. 2 can cancel and you will get 355 or 355 joule. Thank you for watching this video. Thanks a lot and thank you to the Lord.